Hello, ladies and gentlemen. Today we are going to fill out another page in our foldable about how to add and subtract fractions again. So these things that have rational expressions in them, so x's and stuff, and they're in a fraction form. But we're going to take a look at how do we make a common denominator. So we've already talked about when denominators are the same. It's simple. You just add across the top and then simplify at the end. But what if they're not the same? How do we make a common denominator? So we're going to revisit some of your fraction skills from earlier elementary school years, and then we're going to take it to the algebra level here in a minute, okay? So you need your notes and something to write with. Let's take a look at some required knowledge that we need to have in order to add or subtract fractions. We always need to have common denominators. And that means they have to be the same. They have to look identical, be the same value, be the same expression, whatever it might be, they have to be the same. So notice if you have 2/7 plus 4/21, you want to go ahead and go, how can I make these denominators the same? Well, I could multiply the 7 by 3 and then it would turn into 21. But if I change the top, or sorry, if I change the bottom, I have to also change the top of each fraction. So my common denominator is going to be 21, which means this second fraction I'm just going to keep the same. But this first fraction, I'm going to say, let's multiply the top and the bottom by 3 because that's how I would achieve my 21 on the bottom, right? So then this becomes 6. Notice how I'm multiplying by something to create the common denominator. I did not add 14, people. We multiply by a common value to keep the value of the fraction equivalent. So once I do that, now I can have common denominators. So I simply add the numerators. 6/21 plus 4/21 makes 10. 10 what? 21. It means my denominator stays the same, but I've created this new fractional value. At this point, I say, can I reduce this fraction? Can I divide something common out of the top and bottom to make those numbers get a little bit smaller? And the answer to that in this case is no. Okay, let's take a look at a second example. What if you have a 3 and a 5 in the denominator? Well, your common denominator would be to turn them both into 15ths. That is a number that both 3 and 5 can multiply by something to create, right? We need to find a value that, when multiplied, works for both of them. Okay, so if I have a 3 and a 5, I might go, well, could I make them both into a 9 or a 10? No, I have to choose a value that is a common multiple of both of them. So let's multiply this fraction by the 5 then to create the 15 on the bottom, but then I'd have to do that same thing to the top, creating the fractional value of 20/15. Now here, if I multiply by 3 on the bottom, I have to do that to the top, giving me 6/15. So now if I add across the top, now that I have common denominators, I get 26/15. Can I simplify that at all? Can I divide top and bottom by 2 or by 3 or by 5? Not in this case, okay? That's just, how do we make common denominators with plain numerical values? This is the process, and this is something that you did like in elementary school, okay? But now we're going to take it to a little bit bigger level here where we have some x's involved. So what if we have 3 and a 12 for our denominators for these two fractions? I have 2/3 plus x/12. Well, in order to add those two fractions together to create a single fraction, I need to choose a common denominator. Well, I can turn the 3 into 12ths by multiplying by 4, so I'm going to make my common denominator 12. So that means this fraction already had a 12. I don't have to change the numerator at all. But this one, I must multiply by 4 on top and bottom. That's what created the 12 on the bottom and made me 8 on the top. So now if I add my fractions, now that they have the common denominator, what I get when I add 8 plus an x. Like, can I add those two together? Are they like terms? Well, no, one of them's a regular number 8, a constant, and the other one's a variable, x. I can't add those two together. So I would just leave my answer as an x plus 8, or 8 plus x, all over 12. Can I simplify this? Nope. I can't reduce the 8 over 12, people, because these two guys are joined by addition, meaning in order to cancel them out, I'd have to cancel everything or nothing. I can't just cancel a piece. So this is my simplified answer. Let's take a look at another one. What if I have a 7 and a 5? Well, I could make the denominators both 35 And that means I would have multiplied this fraction by 5 on the top and the bottom, making this 20 x's. And if I multiply this by 7, I get the 35 on the bottom. So 1 times 7 is 7. Now if I add across the top, again, these are x's. This is a regular number. So I get 20x plus 7 35ths. Single fraction answer with a common denominator that we created, and we just had to change the numerators to reflect that. All right, so let's take a look at some more. What if we have x plus 1 over 2 and then 9/10ths, and we want to do the same idea? Well, let's our common denominator, tenths probably, huh? Because we can change that 2 into a 10 just by multiplying by 5. So the second fraction I'm going to keep 9/10ths. But this first fraction, I'm going to have to multiply the bottom by 5 to create the 10, right? To make that common denominator. But what I do to the bottom, I must do to the top. That means this whole expression up here is going to get multiplied by 5. 5x plus 5 is what I've now created. So now that I have common denominators, again, I can add my numerators. Add across the top here. 5x's plus regular numbers, constants, 14, right? Because 5 plus 9 makes 14, all over 10. That is my simplified answer. Okay, let's take a look at example 2. Let's make a common denominator here. We have a 2 and a 3. That means our common denominator is going to be 6. So if I need to multiply this first fraction by something in order to create that 6 in the denominator, that's a 3, right? So I'm going to multiply the top by 3. 3 times x just becomes 3x. Second fraction, I need to multiply this by a 2 in order to create that 6 right here. See, in order to make the 6 in the bottom. That means I have to multiply the top by 2. Now notice how we have 2 terms up there. We need to multiply both of them by 2. That's 2x and a plus 4. So now when I subtract, yes, we can subtract across the top. Be careful. What we have here is 3x minus 2x, leaving me with 1x. But I have no numbers here. There's like no regular constant numbers. 0 minus a 4 creates negative 4. Remember, we're subtracting both of these terms. So you can distribute that negative. If that helps you, please make sure you do that. And it's all over our common denominator still of 6. Okay, so there's my simplified answer. Remember, these are joined by subtraction, so we cannot cancel a piece of it. We have to cancel it all or nothing. So let's look at 3 and 4. Common denominators. Notice how this is a 6 and this now has a 2x. Now notice how that x is in the bottom of my fraction. Now when I have to think about that when I create my common denominator, I can't just say my denominator is going to be a 6 because this guy has an x now. But my common denominator has to have representative pieces from both denominators here. So the 6 I like, sure, we could turn the 2 into a 6 by multiplying by 3, but it wouldn't just be a 6, it'd be 6x, right? So my common denominator has to have a 6 and an x. So once we decide our common denominator, now we change each fraction by what it takes to make that denominator happen. So notice how this first fraction had a 6 and now it's 6x. That means I have to multiply by x to make that happen. Multiply the top by x as well. X times x gives me x squared. Second fraction, it was a 2x. Now I've changed it to 6 with an x. That means I must have multiplied by 3 in order to make that happen. So now I must change the numerator in the same way. 7 times 3 makes 21. So now that I have common denominators, yes, I can combine these two fractions. I'd have x squared plus 21 all over 6x as my simplified answer. Okay. Example 4, one more like that where we have an x in the denominator. I see a 5 and a 3, so remember our common denominator would be 15 if that was the case, but now this guy has an x, right? So we need to represent that in our denominator. So 15 times x would be our denominator, or 15x. Oops, so once I decide what my common denominator is going to be, I have to think about what I need to multiply each fraction by to make that happen. So 5 was in the denominator, but now I turned it into 15x. That means I multiplied by 3 and an x. So what do I need to multiply this top by? Well, same thing, right? 3 and an x. Ooh, my pen doesn't want to write anymore. This is really weird. Okay. Sorry, technical difficulties. There we go. 3 and an x right here, making this 27x squared. Now, second fraction, it was a 3x, but now I turned it into a 15x, so that means I must have multiplied by 5. So I must do that to the top. 1 times 5 is just 5. So now across my numerators here, I can subtract 27x squared minus a regular number 5 constant. We cannot subtract those. Those are not like terms, so we're just going to leave them written like that. All over 15x. Okay, beautiful. There's my single fraction answer. All right, I want to thank you for taking good notes. We'll continue working on making common denominators when I see you next. Kincaid out.